No, it's good. Now it should be working, and we are in the time to start.
Oh, and we're at time to start.
So, hello everyone, welcome our next speaker, Daniel Stenberg, and his talk about timing every bolt.
Hi. No margin at all here. So, okay, this is me. I work for Wolf SSL. I do curl all the time. So anyway, ask questions, but do it afterwards because I only have 25 minutes. I'm going to talk fast, and hopefully you'll understand it. So I'm going to talk about curl, of course, because I always talk about curl. Curl is a little command line tool and a library for internet transfer or transferring stuff over internet protocols. And we've been going on this project for a while, and over time, of course, sort of raised our ambitions of what to do in the project. So nowadays we just have this modest aim that we do everything the best possible way, and when it comes to both security-wise and open source-wise. So pretty much, crank everything up as much as possible. And that's sort of the ambition here. Sometimes maybe we fail, but I think in general we actually do a pretty good job. And to use an old XKCD, of course, because you have to do that when you have a slide. So it's really no problem, right? Because we got you. But and how do we do that? And I have a fun slide that I use to show where curl runs. And when I do show this, it's kind of fun because most mortals can not even mention 25 operating systems, right? Because how could you? And usually someone can always anyway find a few that is not included here. But it's kind of a fun map anyway. So it runs in a lot of places, a lot of operating systems, basically any CPU architecture you can imagine, more than one planet, and pretty much, and on, anything we have that connects to the internet every once in a while, it probably runs curl already or will run curl soon. Cars, TVs, vehicles, games, stuff, printers, medical devices, well, anything, right? We estimate that there's somewhere in the ballpark of 20 billion installations of curl, and I think that's really low, the estimate, so it's probably more, but a crazy amount of curl everywhere. So what it puts a little bit of a responsibility and a challenge for us, of course. Sure, what happens when we ship a little bug in 20 billion installations? Could be bad, but of course we write this in the safest possible language. So we have 180,000 lines of C code, and actually, sometimes people think it's a lot or not a lot, but what is 180,000 lines of code? Maybe it's not that big. Maybe it is big. Yeah, but it is 1.14 War and Peace, if you count the words. War and Peace is actually a pretty thick novel. So it's actually quite a lot of code, I would say, for what it is. It transfers data. Okay. So how do we make sure that we actually don't break, or we don't have our heartbleed moment, or whatever you want to call the next problem? So we start out, of course, we host our stuff. So we host downloads, and we have everything on the CDN. Everything is, of course, TLS. We have everything up there so we make sure that we have a redundant websites. It's actually pretty reliable to get data from the curl website. I like that it's 99.95% served of the CDNs. And of course we have the source code entirely served on GitHub, so we use 2FA for everyone. We have 17 people who can push code to the repository. I think we're about 4 or 5 who actually do it regularly. So that's sort of the basic setup. And then, of course, in the source code, how do we manage 180,000 lines of code? So of course, we have reviews for whenever anyone wants to contribute something, human comments and machine tools to verify it. We have a really strict code style these days. It's actually been sort of started out really, really lenient back in the days. Nowadays we have it should look as if a single author has written the code. I think it's really convenient because it makes it easy to read the code. It looks and feels like it was written by a single person. It makes it easier to find, debug, and read code. And of course, we have these days we also ban a bunch of undesired functions that in C is sort of easy to use the wrong way. So it doesn't really matter how experienced you are. Some functions in the C standard is really not advisable to use in code, and we have those. We check for them with tools. We ban them, so you can't really sneak them in by mistake even. We also are what they call reuse compliant, so we have copyright and license information in every single file in the repository, so we should be completely covered in sort of understanding the provenance and who owns what and what's the legal status of everything. And we have a lot of documentation about the source code and internal APIs and everything, and we have had multiple audits. And when it comes to audits, that's fun. We had our first external audit was made in 2016, and they found what resulted in 7 CVEs back then. It's a big task, and it's an expensive thing to do an audit. Someone is going to spend a lot of expensive hours looking at code. We did one later in 2022. They ended up in 2 CVs. I think it was also a much more expensive audit because things go more expensive over time. And but the result from that, of course. And then we had another one in 2024, more narrow audit, because not all audits cover everything, right? 180,000 lines of code is too much for a single audit. But anyway, it resulted in 0 CVs. So it's a little bit of a trend, I would say. So yeah, super expensive. So it's not something that's easy to be done, right, for a small open source project. You have to have someone who just have a very deep pocket that suddenly wants this to happen. These audits, 3 audits, they have the cost of these have been much more than our entire bug bounty for many years. And that has resulted in many more CVs. Okay, so of course we have all of that to make sure that the code looks and feels right, and then we have a lot of tests. So of course we want to make sure that all those 20 billion installations run fine. We have, unit tests, the library tests, and tool tests, and we do test that the code style is right and the indenting and spelling even in the code. And we have a fun torture test, which I'm going to explain separately because I'm so happy about it. And of course, we have the analyzers checking code all the time. And we have fuzzing, be part of the Google OSS Fuzz project, so they keep fuzzing curl nonstop on Google hardware. Excellent thing. And then, of course, in the documentation, I think a big part to really get to the next level when it comes to the documentation in a project is to make sure that the documentation is correct, and we do that a lot with tools. So not only spelling, prose, and using the right words. Like, for example, we try to avoid contractions in the English that we write the documentation in. So isn't something that's allowed in the documentation, then you get a red CI job if you try to write that. And stuff like that, right? Or the common spelling of words. So make sure that everything is consistent and the wording is consistent. The English is sort of written in a way that we think it should be. And then we have, for example, we do have mandatory content. So we do, for example, in the curl project, we have over 500 man pages that we ship. So, and every man page, right, that has to have a certain number of sections, and the sections has to be in the right order, and it should be named the correct thing. They all have that checked, right? And a proper man page for a library, it should have an example section, right? And the example section, it's mandatory, it should be there. And how do you know it works, right? Because we compile every example in every man page in the library to make sure that it's actually compiling. It might still be wrong because we can't run it, but it's still as many checks to make sure that it's actually pretty good. And of course, we verify links and references from cross man pages and stuff like that. So to actually make sure that most of it is in a pretty decent shape. And I wanted to just mention also our torture tests because I think they're pretty cool. So we have a sort of a setup. When you build curl with debug in debug mode, so it's special build for a testing case. We pretty much write a wrapper for every fallible function that we want to monitor, like malloc or calloc or fopen and blah, blah, blah. And then we build curl with that, and then we can control that from the outside. So when we run, so we build that, and then we run a test case, and we count how many fallible functions do we actually call. So when we want to do, like, I want to get a web page from a server with curl, it downloads something. It's, I don't know, 100 malloc calls and blah, 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 something else. So then we make sure that we iterate over that test case, and we make every one of them 100 malloc calls fail once, right? First one, second one, third one, and then rerun. And then make sure that whatever fallible function that fails, it should just fail nicely, no memory leak, no crash, and just exit with an error code. And that's an awesome way to test exit paths, really, and make sure that we always free up stuff and clean up stuff when we exit whatever. In a library, it's pretty important that we never leak memory, right, because it's potentially used by very long-running processes and whatever. Right, and then it actually takes forever to run this on all tests. It's not a fast process. So we actually have a weird system to just randomly run a few of them and not fail every one of them, just to make sure that we can actually run through them, because we have thousands of tests, and some of these test cases, they can easily do many, many thousands of function calls themselves. So it can get a lot. So when we have that, we have everything there. So we have, of course, run everything in CI. So we now, of course, and when I mention CI, everyone has a particular idea what the CI is. In our project, we run CI. So it's just fire and forget VMs. They fire up, they build the code, they run the test cases, and then they're done. Then we throw them away. So we never get anything back from them, really, other than logs from test cases. But anyway, we have a few thousands of tests to do per job, and we do builds on as many platforms as we can, really, that we have. It's a little bit of a, I mentioned 106 operating systems and 28 CPU architectures. A little bit hard to run tests on all of those, so we don't. We sort of focus on a bunch of primary ones, and the rest just has to work. It usually works out really well, because most of the code is perfectly portable, and it's the same code anyway, so mostly the bugs appear on all of them. Right, and we also offer support with a whole lot of different third-party libraries, right? So there's literally millions of combinations of different TLS or compression libraries and SSH libraries and IDN libraries or whatever. So it makes for a really, really large number of combinations too, which is also sort of course, adds to the complication. And we run the CI fuzz thing, which makes a little bit of fuzzing just in the CI run for a short period of time. So when we have these CI, we run now more than 200 jobs per PR and commit. It's a crazy amount of tests, then, because all of them have around 2,000 each. So we're around 400,000 tests per PR and commit. So it's still areas that we don't test very good, but at least we do a lot of testing. And we spread this out over a number of different CI services, just to make sure that we maintain a sort of a maximum parallelism, so that we don't get choked up by a single service. It has been a little bit tweaked nowadays, because we've been sponsored by GitHub, so they have sort of raised the volume for our performance in GitHub. So nowadays we sort of favor GitHub, because we can run more jobs there faster than some of the others. But anyway, we use a lot of them to make sure that we can run on many systems in parallel. But nowadays we then sort of complete all these 200 jobs really within 20 minutes, 30 minutes something. So we've worked really, really hard to sort of optimize and tweak so that they actually finish really fast. Just, I think a year ago, they could take hours, some of them. But it's really convenient to have them finish really fast, so that we know the state of the latest changes right now. And so we spend about 10 CPU days per day right now in CI only. Right. So, and the repository then, there's a question out there. How much does it cost? It costs us nothing. It's entirely free. If we would pay for it, it would cost a fortune. That's the easy answer. So we don't pay for it. We have, as I said, we have sponsors paying for this. So they provide this service for us. So yes, we're happy that they do that. Otherwise, it would be a challenge. So we also have added checks, of course, the XZ way, that we don't have any binary blobs in the repository. We actually have a CI job now to make sure that no one can even, by mistake, add a binary blob, and then because that'll fail your CI. So there should be no way to hide any encrypted payloads in our repository anyway. We have not all our commits are signed yet, but we're sort of going, most of them are. And we, of course, sign tags and we sign releases. And we have perfectly reproducible builds since a while back, so it's really easy to, whatever we ship, anyone is sort of encouraged and welcome to just reproduce it to make sure that we didn't sneakishly insert anything the XZ way or any other way. I still build all the releases locally, but nowadays I use a container to do it, so it's actually easy for anyone else to use the same container. And I just wanted to show you, so you can actually just do this. So this is the latest kernel release. If you just download that and you just figure out when I did the package, because you want the exact same timestamp, right? And then you can just build the same package exactly the same way, and it'll end up a binary copy, right? It'll be identical. And you can even use the script that I provided, so you can actually just download it and you verify that it's actually the same thing, which I think is fine. It's not even that hard once you just get yourself to do it. And I think it's fine. It helps everyone anyone who wants to can verify that is actually, you can make the package the same way I did it, or vice versa. And of course we get vulnerabilities, and we fix them as soon as we can. We alert distros as we should, and we document everything really, really thoroughly. And I have this commitment. I work really hard to make sure that I figure out exactly when we inserted a bug and exactly when we fixed it, so that I can tell that to the world. Nowadays with the CNA, so that we can sort of manage our own CVs a little bit better, less crazy stuff, ideally. And we have this bug bounty too, so we're paying researchers to report stuff. About documentation in the CVEs, then we do that really thoroughly. We provide the metadata as JSON, and we document everything. Of course, we don't provide a CVSS score, which is awesome, because then someone else will do it for us, and then it'll be super crazy instead. I won't get into why, but CVSS, I hope you all agree with me, it's a totally broken system. So we decided pretty much to not participate in that dance. So we get forced to participate in it anyway, but still, that's the way we do it. So for example, you can do this. You can check out the curl version on the website, and it'll show you exactly which vulnerabilities it contains. From version to version, we can even get it in a nice graphical overview. Those versions have those vulnerabilities over time, blah, 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 and all those are clickable, of course. So in the bug bounty, we have this started 5.5 years ago, approaching 6 years, I think. So we paid out more than $85,000 by now. A small amount compared to those audits I mentioned previously. It has resulted in 76 CVEs, soon to be 79 CVEs. So it's a pretty good system. 15% success rate then. Of course, some of the others that we get are just ordinary bugs, right? So not everything else is crap, but there's a fair amount of that too. And we always sort of disclose all of them after the fact, so that you can follow the discussion and see whatever silly decision we made. And of course, we have a fun race with the rest of the world right now, with the AI slop sort of increasing in this amount. We're actually right now, we have this about the same rate of valid reports as in AI slop reports. It's sort of in the same ballpark, somewhere around 10%, 15% of the submissions. And of course, I couldn't do this talk without sort of showing this book cover, because it's a very popular book. No one has really finished it, or I've been told many times that it only takes a weekend to rewrite it, but apparently that weekend hasn't happened yet. So we're not going to rewrite curl in any language. We're not going to rewrite it at all. It's there already. So we're just patiently, iterating and polishing over time. So there's not going to be any rewrite. And when it comes to Rust, it's a good effort. It's possibly a great language, but we're not going to use it. But we can still use third-party dependencies written in Rust, right? So if there's a TLS library or another library that we want to make curl use as part of its functionality, right? So the TLS library, for example, tend to be something you use with curl. That could be written in Rust, and then we can use that. So that's the way we're going to use. I think we're going to see more Rust sort of in that kind of aspect going forward in curl. So that's how we try to stay best in class when it comes to security and open source. Thank you. There's a question.
How do you manage dependencies?
How do I manage dependencies?
XZ type.
Sorry?
XZ type. Someone tried to...
How, right, but okay, how do I manage dependencies XZ type? Well, I have a sort of a kind of a fun, unfortunate position that I don't really have dependencies in that way. Since I ship curl as a release as source code tarball, right? So there's actually no dependencies there. The dependencies are managed by those who build curl and get a lot of dependencies when they decide what to build curl with and use. So it's a little bit of a way for me to say, that's someone else's problem. So I build curl, someone else deals with the dependency problems. Oh,
when you say all commits are signed, or nearly all commits are signed, how do you handle external pull requests? Do you rewrite the commits, or do you pull them with
I always do rebase of commits, so yes, they're rewritten. So okay. Yeah, so if when I merge someone else's commit, it'll be pushed and committed by me, right? So it's going to be signed by me.
Okay. Do you measure code coverage? And then look at new code introduced.
Code coverage is a really hard question. Yeah, so yeah, code coverage, that was the question. So it's really hard. Yeah, I tried to for a while, but since curl is such a mess with different backends, different dependencies, and different options on and off, it turns out to be really, really hard. What does it mean? What is code coverage really? Code coverage X out of what? So it turned out to be a really weird number to get. So I actually stopped because it was really hard to even explain what we measured and how to use it and what do we want to communicate with it. So no, I don't do that anymore.
I'm interested in your torture testing. You talk about fallible functions. I wonder how many of those you have, and do you generate the wrapper functions like manually, or do you?
So the torture setup we have, they monitor a bunch of fallible functions, and yeah, we have written manual wrapper functions for them. But because they don't tend to increase, right? It's the same set. We basically monitor the memory allocations, file handling, and yeah, that's pretty much it. So there's a limited set. They're like 8 functions or something. So it's a pretty narrow set, and it's pretty fixed.
So you mentioned there are some C functions that are banned on curl. Can you give examples?
Yeah, C functions that are banned in curl is, for example, gets, or now since a while back, scanf we don't allow. We don't even use string copy anymore. And a few of the other, of course, we don't use sprint either. And some of the other more natural ones that anyone can think about. But I think recently there was some more scanf and string copy are the newer ones that we sort of avoid, because basically most of these we decided to stop to use because sort of by experience we see that they don't really add much. When we use them, it tends to lead us into the wrong fixes, wrong solutions. So we write better code, we create better solutions by sort of forcing ourselves by avoiding those functions.
So you say you have 15 maintainers in the program. How do you get new maintainers into the program?
How do I get new maintainers? I don't know.
I mean, we all age, so do you have a plan?
We're all, yeah, the average age of the maintainers, it increases 1 year every year, right? So yeah, I don't know how to do that. Man, that's a universal open source problem, right? How do we recruit new maintainers and preferably younger maintainers? So I don't know. I don't have any good solution or answer to that. My time is up. I have to stop. Thank you.
Thank you.